Good morning, everybody. My name's Michael Noble, and this is Giovanni Gongora, and we're from the security team in Parity Technologies. Parity Technologies writes the code that ends up in the Polkadot SDK. And we in the security team, we cover all aspects of security within the organization, from user device management through to making sure the code that we ultimately deliver has as few vulnerabilities as possible, everything in between, and much more besides. So we're going to talk this morning about security in a decentralized system and how it's different and how it's the same in some ways than security in a centralized system. And what we're finding are two things. First off, compliance doesn't work in a decentralized free-thinking organization. And at the moment, AI is killing us. So we're under constant attack by people driven using AIs in order to help enhance their attacks on our systems. So what do we do about this? First off, we have to look at the culture and how we approach security within the organization to make sure that it's the best fit and that it works well. And then secondly, we actually have to take AI and make it work for good rather than evil. So the first bit, and we talk about the humans and the people in the organization. Because actually, most security incidents that we see within Parity are driven by humans. And it's not an attack on the cryptography or the chains themselves, but it's mostly social engineering, phishing attacks, people clicking on the wrong link at the wrong time. If you need an example, then you just need to look at the attack on Drift yesterday, where $280 million were taken, and it's looking very likely that that was a social engineering attack. And so we have to take into account the humans that work in our organizations, that consume our security policies and actually implement our security policies as well. And we have to work with them in order to make sure that we've got the best possible security posture. This is kind of a deliberately provocative slide, but what it's meant to show is the spectrum of how you can ensure the best possible security outcomes in any organization. So on the left-hand side, you've got very strict, very severe compliance. Everything's locked down, buttoned up. The team can't really breathe unless they're given permission by security to do so. On the other side, you've got anarchy, which is no security whatsoever. Now, it doesn't take much imagination to know that no security is a bad thing, and that results in bad outcomes. But I'm actually going to argue that over-compliance is equally as damaging, especially in a decentralized organization with a decentralized culture. Because the humans, the people, react badly against that, because we're seen as being in the way and stopping them from doing their job. And then there are two behaviors that come out of that. First is what's shown on the screen, which is malicious compliance. I'm not here to think. I'm just here to check the boxes so that I can move quickly on to the next stage. Even when I have more domain knowledge than others, I'm possibly even going to do things that I know are wrong because we're a compliance organization and I'm just motivated by checking the boxes. The second behavior is, well, I can't go through it, so I'm going to go around it. So security have locked down my machine, so I can't take an offline copy of a document. I can't print it off. Well, I'll take a picture of it with my mobile, run it through AI, and hey-ho, you've suddenly got an uncontrolled document that can go anywhere and do anything. And that's a bad security outcome. So I would say the two extremes of that spectrum are equally as bad. And where you want to be is to land somewhere in the middle. And I know it says sweet spot, but it's still kind of a spectrum. And if you were to ask me where the exact sweet spot is, I'm going to give you a not very good answer, which is, it depends. It depends on the organization. It depends on what you're trying to achieve. It depends on the culture of the team and of the individuals. And even within Parity, we've got people at either end of that spectrum, as you can imagine. So we have teams, for example, who are very used to compliance. They come from a Web 2 background. They themselves are probably heavily regulated, like the people ops team, the finance team, the legal team, for example. And so they're actually more comfortable working to the left of the diagram. On the other hand, we've got our developers, and they're very much don't get in our way while we move fast. And they're very much on the right-hand side of that spectrum. So how do you square that circle? How do you talk to those two very different constituents at the same time and ensure a consistent security policy that works? And that's the important thing. The fundamental thing here is that an imperfect security policy, but which is understood and agreed and implemented well, always works better than a perfect security policy that's misunderstood and therefore not implemented well. So how do we do that? Here's an example. We've just taken a simple example of endpoint management, user devices. And what we've done is we've implemented a wide technology stack and also two different ways of communicating that information to our community. So on one side of the spectrum, we've got the traditional endpoint management tools like CrowdStrike and Jamf, which can monitor the processes running on your machine, shut things down if they see anything nefarious happening, isolate your machine from the network if it's really bad. And Jamf, which can push automatic updates to everybody's device and make sure that there's no vulnerabilities in the software that's running on the device. The teams that I talked about that like a bit of compliance, the legal team, the people ops team, they're good with that. They like that because they like the protection that it gives and they don't really want to think about it too hard. But as you can imagine, many of the development teams react very badly to having centralized control systems on their laptops. And will tell us very forcibly, we're not having that stuff on our devices, so don't be doing it. So at that end of the spectrum, we've implemented FleetDM, and FleetDM is an open source tool, which is great. The developers like it. They can go on GitHub, they can look at the code, understand exactly what it does. And all it does is takes an inventory of the device, what software and packages are running on the device, and what version they're at. And then sends that to a Parity server in a Parity cluster. So again, data's not leaving our network, it's not going outside our organization. We're in control of that. So for those reasons, the developers, they don't really mind FleetDM. And we've implemented a system where it doesn't matter if it's CrowdStrike or FleetDM that's running on your machine. Both will provide similar data to the stack in the middle, which can then be presented in two different ways. And what we've done is we've tried to gamify it a little. So every user's device has a score out of 100. Obviously 100 out of 100 is good. You're well protected, you're doing well. If it's below 100, then the stack actually gives you the information about what it is that's keeping your score below 100 and gives you actionable items, tells you exactly how to fix that. And so that's what's shown on the bottom half of the slide here. So this is a splash page that users see whenever they log into Workspace. So it's somewhat gamified. It's giving you the score and sort of nudging you that you want to get that score up as high as possible. And it's presenting you the information in an easy to consume form. It's saying, here's what's wrong, and here's the exact thing that you need to do in order to make things better. And so that's a nudge. That's not a compliance thing. That's just giving information to users so they can do something about it. And so that speaks to the right-hand side of that graph, a bit towards the anarchic side. And it's about self-service. It's about giving people the agency and control and the ownership of their own device in order to make sure that it's as safe as possible. But we can also present the data in a different way, which is at the top of the slide, which is a good old-fashioned leadership roll-up. This represents a hierarchical organization with leaders and leaders of leaders, and the scores aggregate up. So a leader's score is the average of everyone within their team. And that means that each team lead, each leader, can actually make their own decision as to whether they're going to go the compliance route and talk to the individuals and say, your machine isn't particularly safe, you need to do something about it. Or take a more casual view of, well, I understand that actually they're not accessing critical systems. They can't do much damage if anything goes wrong. And it's, again, represented in a nice, easy to consume view, red, amber, green. Green's good, red's bad, amber's a little bit in between. A very important thing that we do in Parity is make sure that the code that we ship has as few vulnerabilities as possible. And traditionally, that has been done through security audits, which come at the end of the life cycle, which is always a fun place to be, and is very compliance-based. So I'm going to hand over to Gio, who's going to talk about how we're shifting that, and also a little bit about how we're using AI for good.
Yep. Hello. Thank you. And well, I'm going to talk a little bit more about the technical side. I guess if you're an engineer, you probably have been at some point or at any point trying to figure out if you need a security review or how you're going to do it. So that's what we are going to discuss right now. There's actually two sides that I'm going to talk. Is more about the security reviews and the vulnerability disclosure, because those are tied together, but we will start with security reviews. If you see, for example, I have these AK audits, and it's interesting because in the blockchain space, we acquire this concept of security audits. But if you go to the financial system, the security audits are when you have an external person that comes to your organization and he has a long checklist of, do you comply with this? And it's a big checklist that you just fill. And if you actually have it, everything done, then you are allowed to operate. That's not exactly what we do or what you want to do. We do security reviews. We try to make sure that what we are shipping is actually as secure as possible. I try to put some of the questions that usually, either if you are an engineer and you don't have a security team, these are probably the questions that you ask yourself. But if you have a security team, these are usually the questions that you will get asked. Usually it's like, is implementation ready? Usually that's not the case. Usually it takes more time. It's more difficult to go to delivery. Have you engaged with auditors? Yes, they will tell you yes, but getting a quote for an audit is not engaging with an auditor. Engaging with an auditor is mainly when you try to explain exactly what do you want to get audited, and especially how complex your system is. It's unsustainable for you to go to an auditor and say, hey, I want this audited. It's a whole blockchain. It's a whole protocol. Can you do it? Yes, sometimes if you have the money for it, then that's possible, but it's unsustainable even for you, for whatever the outcome of the audit is. If you need to resolve design decisions, or if they actually find vulnerabilities. And that goes to the scope of the review. It's usually really difficult to really analyze or decide, okay, we are only going to audit this because this is the most important part. We don't care about what happens on this side because you, for example, I don't know, you need millions of Ethereum just to get $1,000 or something like that. So why are we even checking this in first place? And then finally, when you ask people, do I need a security review? Most likely, what they tell you is no. But in my experience as an application security engineer, these are actually the answers that actually they represent the reality of the questions. So yes, is implementation ready? Most likely not. Have you engaged with the auditors? Kind of. Again, getting a quote for an audit is not engaging with the auditors. Is the scope of the review clear? Most likely not. And do you need a security review? They probably are going to say no, because every engineer that I have met or not every engineer, but at least I'm not going to put everyone, is going to be for the 90% of the time, they always think that they ship secure code, that all the code that they do is secure. So what we have been doing is that we have been developing an internal platform when engineers can do security reviews on demand and at scale. And they can do it from the beginning. They don't need to wait until they are really done with the implementation. They can just trigger a review, mid-development, get total input about, hey, is this something secure? I'm doing something bad or I'm doing something wrong. What is different from this? We have many years of security reviews, many years of knowledge that we have put into our internal tooling, our security tooling. So what developers are getting is actually intelligence from the security reviews that we had done in the past exactly when they need it. So they don't need to wait months, weeks, or whatever the time is on development to actually know that what they are doing is actually secure. So that's part of what has changed us, and it has had some effects. Like we actually have seen people using it and making sure that what they're building at the moment is good, and we have really good results. Now, what about vulnerability disclosure? Of course, it depends on the type of ecosystem that you have. In our case, it's Polkadot. There's a lot of projects and people that build on top of it. So for us, and I think it's important for engineer teams as well, is that the vulnerability disclosure is part of how you communicate with the ecosystem and you make it more secure. We personally have been part of multiple incidents, or at least situations when we found that there's a vulnerability in the protocol, and then we need to go and talk to other people and other projects that, for example, have this situation, and they need to fix it and do something about it. And at the end of the day, these are the things that you get with a vulnerability disclosure. However, the efforts that you need to put on it for it to work and to have a sustainable return are high. I'm not saying that every team should do this. It's unsustainable, unfortunately. But if you have the opportunity to have a security team that is in place.
Sorry, we ran out of time, so if you want to say just the last sentence.
Yeah, for sure.
Okay.
Yes. Yeah. I mean, you can go.
Yeah, so just to conclude, what Joe has just said is really, really important, and it kind of proves that getting the right spot in order to engage with the people within your teams is really important. And we've shifted that auditing away from what feels like compliance into away from that a little, and our engineers have really, really embraced it. We launched it a week ago, and already in the space of a week, more lines of code have been put through our system than were looked at by a human auditor over the last 2 or 3 years.
Okay.
Thank you.
Next.
My back.
Okay, go again. Okay.